One of the most fundamental questions in chemistry is how do they know? How do they know what these chemical formulas are? You can't see these atoms, you can't see these formula units. How are you able to figure it out? And the way that we're able to figure it out is by looking at ratios using our mole calculations. So that is something called an empirical formula. All right, the empirical formula is that lowest whole number ratio of the elements in a compound. And in class, we usually see either sample problems where a machine could give us a percent composition, or in class, in lab, we can actually do this with experimental lab data. We can weigh how many grams of each thing are in it and find what their combined value is, and then change them all into everybody's favorite word, the mole. Okay, everything is based off of the moles. So a mole interpretation of your empirical formula is literally that lowest mole ratio of your atoms in your compound. Okay? So here are some examples of things that are empirical formulas and are not. Okay, so CO, which is your carbon monoxide, it has an implied one here and an implied one here, which means I have 1 mole of carbon for every 1 mole of oxygen. That one atom of carbon for every one atom of oxygen can be multiplied by 6.02 to get 1 mole. So it's very, very easy to use our mole calculations in pretty much everything that we do. Okay, NH3, your ammonia, okay, is a 1 nitrogen to 3 hydrogen ratio, which means 1 mole of nitrogen for every 3 moles of hydrogen. And then we have our Fe2O3. Okay, this is your iron 3 oxide. That means we have 2 moles of Fe for every 3 moles of O. All of these are the lowest whole number ratio. 1 to 1, 1 to 3, 2 to 3. We can't divide these out and reduce them down to any smaller whole number. Okay, so what are not examples of empirical formulas? A formula of N2O4. 2 to 4 is not the lowest ratio. Okay, we could reduce that down to a 1 to 2. So this is more of a molecular formula, which you'll see in the upcoming videos. C4H10, which is going to be your butane. A 4 to 10 ratio is not the lowest number, okay? The lowest whole number ratio. It can be reduced down to a 2 to 5 ratio. And then down here, Fe1O 1.5, 1.5 is not a whole number ratio. Okay, so we actually have to multiply the whole thing by 2 to maintain that balance of a 2 to 3 ratio. Okay, it's like finding that nice common uh, whole number multiple. Okay, so these are the steps for calculating an empirical formula. Okay, first things first, get an easy point, which is able to wow anybody grading your papers, whether you are doing this in chemistry or eventually if you take AP chemistry or something in college. Always write down, assume 100-gram sample. Literally, write that sentence, because if you have percentages, they are going to change into grams, exactly like that. Okay, then you can change your masses into moles using your periodic table and the molar mass. Okay, once you have all of your moles, then you can set up a mole to mole ratio. And then your goal is to get to the lowest mole to mole ratio. So what we do is we divide all of the numbers in that ratio by the smallest number of moles. That will make a 1 to something ratio. And that ratio can be used to make a formula. So you'll see a little star next to number 7 here, because sometimes if it's not a whole number, you might have to double it or triple it in order to get a whole number in there. So sometimes we're going to use number 7, and that's going to be in the next video that you'll see here as well. All right, so let's do a good sample calculation. All right, so empirical formula problem number 1. Calculate the empirical formula of a compound that is 40% sulfur and 60% oxygen by mass. So first things first, right? Assume a 100-gram sample. You always have to document where you get your numbers from, okay? So this will change my 40% sulfur into 40 grams of sulfur and my 60% oxygen into 60 grams of oxygen. All right? Now that I am in grams, now I can convert into moles. So please get your periodic table. Please get your calculators. You're going to need those. Okay? So now let's look up what the molar masses of sulfur and oxygen are. Okay, 1 mole of sulfur is 32.07 grams of sulfur. And I put grams on the bottom because I want to get rid of grams and get into moles. So I get grams and grams to cancel out. And then oxygen, I know 1 mole of oxygen weighs 16 grams. And I am going to use green to cancel those out. Okay, so let's figure this out. 40 grams divided by 3207 grams is going to be 1.25 moles of sulfur. And in my calculator, 60 divided by 16 is going to be 3.75 moles of oxygen. Okay, so now I'm going to take these two values, 1.25 moles of sulfur for every 3.75 moles of oxygen. And what I am going to do now is turn this into the lowest whole number ratio. I can't have a formula that is S1.250 3.75. These are not whole numbers. I can't split these atoms, so this doesn't work. So which is my smaller number here? 1.25 or 3.75? 1.25 is the smaller of the two numbers. So divide this. This is 1 mole of sulfur for every 3 moles of oxygen. Fabulous. So now what do I do? Now I take my 1 mole of sulfur for every 3 moles of oxygen and I use that to make a formula. 1 mole of sulfur for every 3 moles of oxygen. Oh wait, I don't write the implied one. I just write SO3. That is my formula for this compound that is 40% sulfur and 60% oxygen by mass. Okay, so this is called sulfur trioxide. Okay, if you can use the formulas to figure out percent composition, you can do the opposite. Use the percent composition to figure out the formulas. So to show it to you, again, nicely typed out, okay, first you assume that 100-gram sample. You change your percents into grams. That's what that assume 100-gram sample allows you to do. Then you convert your grams into moles because we don't have percents on our mole roadmap. So you divide by the molar mass of each one. And then you get 1.25 moles of sulfur for every 3.75 moles of oxygen. Okay, set up your two values, 1.25 for every 3.75. Divide both numbers by the smaller of the two numbers, and you get a 1 to 3 ratio. So that means sulfur trioxide. So if you look at SO3, that 1 to 3, if you went back here to where we have our decimal points, that is a 1 to 3 ratio of these guys right here. Sometimes it's easy to see, sometimes it is not, but our formulas have to be whole number ratios. Okay, the next video is going to have a level 2 and a level 3 problem for you to look at.